We have already seen now the concept of high pressure and the low pressure. High pressure is a result of the sinking of air, and wind moves then from the high pressure to the low pressure. So now we will discuss about the three forces actually that drives the surface winds. The first is the pressure gradient force. So this is nothing but the difference in the pressure gradient. So if suppose this is the 1000, this is 998, and this is 996 MB. So wind is going to move from the high pressure to the low pressure. So this is the pressure gradient force. The second is the Coriolis force. Coriolis force is the influence of Earth rotation on the objects that are not attached to the Earth. So I'm again repeating, this force acts on the objects which are not attached to the surface of Earth, and it happens because of the rotation of Earth. And what happens in the northern hemisphere, the things which are not attached to the Earth, it will deflect to the right, while in the southern hemisphere, the things which are not attached to the earth, they deflect to their left. So this is how it becomes a very important force to understand when we study the global circulation. So Coriolis force is the force which makes wind divert to their right side, okay, right side in northern hemisphere and left side in the southern hemisphere. So Coriolis force becomes a very important force. It is greater on the north and the south pole, and it is absent on the equators. Third force is the friction force. So friction, so we are holding the air back, we are holding the wind back, right? So it acts as a friction. It is caused by the topography of the region, the vegetation, the hills, the buildings. So that is how the winds become slow. Now let us see, we'll put all these forces together and let us see the resultant wind. These are the three isobars. So now pressure is decreasing. This is a pressure of 1020 MB, and it is decreasing then from 1020 to 1016 and 1012. So air is going to move from high pressure to low pressure. This is the pressure gradient force. Now the second force is the Coriolis force. Suppose this is in northern hemisphere, so the wind will drift to its right. Wind will drift to its right because of Coriolis force. And there would be a friction force which will move it backwards. So this is a friction force. Now if we put all these three forces together, we get a resultant wind which is 45 degree to the isobars. So this is a very important point. Now this resultant wind will have an angle of 45 degrees to isobar. So this is isobar. Isobar means the area of the same pressure, the line of the same pressure. So the resultant wind will have an angle of 45 degree with respect to the ice. Now let us see it with a different angle. Here we have a high pressure cell and here we have a low pressure cell, and we put a isobar around high pressure and isobar around low pressure, and we put certain stations here. So now wind would travel 45 degree from the isobar. -45 degree with respect to isobar. So it will move from high pressure area, from the center of high pressure outside to the low pressure with an angle of 45 degree in clockwise direction. Right. Similarly, now we have a low pressure center and isobar surrounding it. We fix some of the stations, and now we will have inward movement of air from high pressure to a low pressure. Now this will be in anti-clockwise direction. Anti-clockwise direction. So this way, this wind will be southwest wind, because wind we normally named it by the direction from which it is coming. So this is southwest wind, this is northeastern wind, this becomes your, this is northwestern wind, this is northeastern wind, and this is southeastern wind. Wait. Similarly here we see this is the southern wind, this is the eastern wind, then this is again northwestern wind, and this is southwestern wind. Right. So this is a concept which we study for the direction, resultant wind direction with respect to an isobar. Let's move ahead now to the next concept of global circulation. Now what we are going to do is, whatever we have learned, the concept of pressure, atomic atmospheric pressure. This atmospheric pressure is the result of difference in heating of the Earth's surface, pressure, density, air sinking, air rising, flow from high pressure to the low pressure. So all these things now we will put in the global circumstances, and let us see how the air is getting its circulation in the earth, on the earth. So this is earth, and I'll write here the equator. So this is 0 degree north and south. Now this is the area which is getting the direct rays of the sun. So here we get hovering around the equator, meandering is ITCZ. This is ITCZ with its intertropical convergence zones. Intertropical convergence means coming together, zone. Intertropical convergence zone, and it is a low pressure area, right? It is a low pressure area. It is a low pressure because here we are getting direct rays of the sun, so air is rising. Air is rising. So it is this whole ITCZ, the intertropical convergence zone. It is a complex of thunderstorms and rainfalls, and it influences the distribution of rainforest all around the world because it rains continuously here. So this ITCZ, like with other pressure belts also, we will see it migrates with sun. Migrates with sun, what I mean to say is summer solstice, when the direct rays of the sun would be on 23.5 degree north, Tropic of Cancer, then this ITCZ will move to the north side. Similarly, in the winter solstice, it will move to the south, and similarly other pressure belts also, they move with the position of sun. Right, let's move now a step further, north and south. North, and this is south. So this is 30 degree north, and this is 30 degree south. Now it is subtropical high pressure belt because air is sinking here. The sinking air now will diverge to meet at ITCZ, that is a convergence zone. So subtropical high pressure belt. Subtropical high pressure belt. So this is the area of divergence, while ITCZ is an area of convergence. This subtropical high pressure belt, it influences the distribution of desert all around the earth. Like ITCZ, which governs the distribution of rainforest around the world, this subtropical high pressure belt, it deals or it influences the distribution of deserts around the world. Let's go one step further north and south, which is 60° north and 60° south. And here we get, this is high pressure, this is high pressure, another low pressure. We get another low pressure which we call subtropical low pressure belt, subpolar low pressure belt. So ITCZ, subtropical high pressure belt, then subpolar low pressure belt. But it is not such a strong low pressure area as ITCZ is. So again, all these pressure belts, they shift with the shifting of sun from the summer solstice to the winter solstice, and here we have again another high pressure belt, polar highs. So because here we get very less sun radiations, so air is very cold, so all air is dense and then it moves. Right, now we put the second concept here. This was the concept of high pressure and low pressure due to difference in the heating of the surface of the earth and also the convergence and divergence of air. Now there is a pressure difference in each of these cells. Now let us put the wind direction from high pressure to low pressure. Now between 0° north to 0° north and south, that is equator, we are having wind of this direction. Which is northeast trade winds. Winds diverging from the high pressure, and then we have convergence and interconvergence zone. So northeast trade winds because their direction is from northeast. Right? Similarly, in the southern hemisphere, we have a mirror image of this. Which is southeast trade winds. Southeast trade winds. Going to the above shell, we get again from low pressure to high pressure. From high pressure to low pressure, another set of winds. From high pressure to low pressure. 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 And these winds are called westerlies. Similarly, here also, from high pressure to low pressure, 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 and these are also called westerlies. Now here at poles which are very cold and lot of air sinks there, and from sinking it happens and there is a low pressure, a subpolar low pressure belt. So now we again get from high pressure to low pressure. And these are known as polar easterlies. Polar easterlies. Similarly, here in the southern hemisphere, we get polar easterlies. So this is the whole global circulation, what is happening around the globe. Starting again from the ITCZ, the intertropical convergence zone, because here if you see from the subtropical high pressure zone, the winds are coming and converging. They are coming together and then again they are rising. Right? So they are rising, creating a low pressure belt here. these winds from subtropical high pressure belts, in northern hemisphere they are known as the northeastern trade winds. Similarly, in the southern hemisphere they are known as southeastern trade winds. Going a bit ahead, then we find westerlies which are moving from subtropical high pressure belt to the subpolar low pressure belt. Same is in southern hemisphere. Then moving further between 60° north to 90° north, we get polar easterlies which are from the polar highs, which is a very high pressure belt. As it is very hot, so air is very dense, we get high velocity waves which are very cold from polar highs to the subpolar low pressure belt. And this is a region where the warm southern air meets the cold weather fronts from the polar highs, and this is the region of thunderstorms. The concept we will deal with in some time from now. So thunderstorms. So this is a very simple global circulation model, and it follows with logic, like what we have started from the high pressure to the low pressure, and the cause of the high pressure and low pressure is the difference in surface heating, the region of convergence, the region of divergence, then the winds which gets their name from which direction they are coming, from the direction where they are coming. Let's now go ahead and see it from a different angle, from a different cross-section angle, and see what is happening at the surface and above the surface. Right, so let us see it. This is my surface starting from 0°, 30°, 60° and 90°. This is north. Similarly, in the southern hemisphere we have 30° south, 30°, 60° south and 90° south. We know here we have a high pressure. These are the subtropical low pressure belts. Then we have subpolar high. We have at equator ITCZ, that is a very high low pressure belt. Then we have subtropical high pressure belts. Then we have subpolar low pressure belts and polar highs. Now from high pressure to low pressure we have winds like this, right? From high pressure to low pressure, again from high pressure to low pressure, from high pressure to low pressure, from high pressure to low pressure, from high pressure to low pressure. So these are the surface winds. Now this is at surface. Let's draw a tropopause now. Let's draw a tropopause. This is my tropopause TP. Now here this is ITCZ, that is the intertropical convergence zones, and here we see the winds from the subtropical high pressure belt 30° north and 30° south are converging. So now this converging air has to go somewhere, and this is a low pressure belt, so it will rise, and reaching the tropopause it will diverge. You remember the concept of water ball, when we threw it up it blowed away in two directions. So here it diverge, and here where we have a high pressure belt, it's 30° north, it will converge. So this first cell, it becomes the main heavy cell, and this is known as Hadley cell. The main precipitation cell. Now it's very easy, you can fill the rest of the things. Again we have a low pressure here, so it is convergence. It will go up, it will diverge, then again it will go there, and convergence will happen like this. Similarly in the southern hemisphere, the low pressure, it will rise up, it will diverge on the above surface, then again it will converge. So this becomes the complete wind circulation pattern at the surface and above the surface. So it's a very simple concept. You can just again revise it, draw yourself the whole globe, the different pressure cells, the result of those pressure cells. The important part is ITCZ, that is intratropical convergence zones. Then you can mark yourself the winds which are present, starting from the northeast trade winds in the northern hemisphere, then westerlies, and then polar easterlies. Then polar easterlies and westerlies, they collide. The warm air and the cold air from the polar regions, they collide, and it results in thunderstorms in that particular mid latitudes, the subtropical, the subpolar low pressure belt. So this is all about the global circulation, and this is more than sufficient if you understand the concept once. Very easy concepts to understand.